Hi, me again. Good morning. So, what I've been trying to look up is the use of timer 0 in the PIC10F200. I know it's there because when I search for it, I can find it. It starts talking about the timer module on page 23 of the PIC10F200 data sheet. And then GP2 pin has the capability to be used as a clock input to TMR0 as the T0CKI pin. Well, that's all great. I know how to use the timers in assembly language for a PIC18 chip, but I don't know how to do that with the 10F200. And Google searching the timer PIC10F200 does not yield an immediate result. So I got a little desperate, and I was just looking for PIC10F200 code. And then I had the idea to go to GitHub. Maybe I can find some code that way. So I typed in PIC10F200. I can even look at the different languages. Let's try assembly. This PIC10F came up. When I click on it, there's 3 different ASM files in here. So I clicked on the blink sketch. Maybe somebody will be using a timer in a blink sketch. I'm hoping for that. But it's not the case. So here is the blink program. Okay, well, maybe I'll abandon trying to find timer code. So I plugged that blink program into MPLAB, and it works. But I don't know why people do things like this, and I'm not being rhetorical or sarcastic. I'm serious. Like, why do people set up their port pins like this? Is it to be clever or a hot shot? Or maybe I'm stupid and I don't understand why people do that. So this is really setting GPIO2 as an output. This move LW tilde 1. What's that? It's like a shift. I forget what you call that. T0CS. That relates to this option register, timer 0 clock source select bit. And now we're talking about the T0CKI pin. So this is either using the internal clock or maybe GPIO2 as the clock pin. Something like that. So I don't know what this line of code does. It looks intentionally complicated. But if I go to this PIC10F list of codes, he has another code here, main.asm, and it looks like more of a template type of code. And he gets into explaining this really obfuscated type of code here as to what this is doing. And it basically just says, in this instance, it's setting GP1 as an output. Oh, and by the way, if I sound annoyed in this video, it's because I am. Sometimes I get that way, especially trying to program PIC chips. It's hard to find accurate information. Anyway, so I'm going to read this in. Oh, by the way, this is not a great video you're watching. But anyway, well, why don't I learn what this is about? I'll read the comments. So this is one of those complicated ways of setting up a port pin. It basically sets GP1 as an output. Not the way I would do it. But anyway, move a literal value to the working register. I guess that's what this is doing. Working register tilde, which is, I guess, is a not instruction. 1, and then this shift instruction. I used to know what that meant. Insert 1 into register at position 0. Shift left to position to 1, so turn this number into this number, and then invert the whole thing, and then we get this, and I suppose this would make GP0 an input and GP1 would be an output. So kind of looking at this, can I say a bad word? This this wise guy's code, he's basically being tricky on purpose, which I don't know why people do stuff like that. And he pretty much could have just set the code more like this, and yeah. So anyway, that seems to be how this guy does things. Like as if this isn't complicated enough already. So you want to enable GPIO pin 2. That's all he's doing. But I had to look at that other code that he's got listed to interpret what this means. So this is his code as it's written. I'll make a correction here so as not to be a jerk. Well, actually, he sets up GP1 and 2 as output. So this is doing something different here. This is adjusting this bit 5 in the option register. Okay, just for reference, this option SFR in the PIC10F200 is all 1s on reset. So here's the option register, which I have much to learn on, but apparently everything is set to 1 on reset. So if he's making an adjustment, he's having some kind of timer clock source on the internal cycle clock. He's done here in his code with this really complicated way of setting GP1 as an output. He's setting everything to 1s except GP1, which is 0, which means output. By the same method, it seems like he's setting this T0CS pin as a 0. And once again, the timer 0 clock source select bit, setting that to a 0, transition on internal instruction cycle clock, setting that to 0. Is that the same thing as enabling GPIO2? I'm not really sure, but according to this pinout diagram, GP2 is associated with this T0 clock function, or the internal oscillator thing. So anyway, I took this guy's code and I uploaded it, and it basically is a blink program, and it blinks 2 LEDs back and forth, that being GP1 and GP2. I'm looking at it on my PIC10F200 right now, and it's working. So I guess move a literal value to the working register binary 110 11111 might be the same as this complicated line here. So I'll just comment that line out, and I'm going to clean and build and upload and see if the program still does the same thing. Well, it says the build was successful, so I guess the coding was fine. So I guess this code is acceptable, and it moves everything to this option register. And while I'm at it, since I'm learning, I will read in the description of the option register. The option register is a 8-bit wide write-only register which contains various control bits to configure the timer 0/WDT watchdog timer, prescaler, and timer 0. By executing the option instruction, the contents of the W register will be transferred to the option register. A reset sets the option 7 to 0 bits. So I feel like I'm getting closer to using timers in the PIC10F200 because that's what we're adjusting, and then these, I guess, lower 4 least significant bits deal with the prescaler. But anyway, I was going to try to upload this, see if it does the same thing. It seems to still work the same way. Okay, so while I'm looking at this piece of code, I guess I'll go through it even though it's kind of redundant, having done similar projects before. Okay, so move LW, all these ones and zeros, this sets GP1 and GP2 as outputs with these 2 zeros here, and then trace GPIO, copy contents of W register into GPIO registers, so that sets up the GPIO pins as output. Then there's a loop, bit set F, GPIO, GP2, set GP2 high, bit clear F, GPIO, GP1, so it simultaneously sets GP2 and clears GP1. Then it calls a delay, which is here. Here's the delay routine. It takes a decimal value of 5 and puts it in the working register, and then it puts that working register into a bunch of files, 10, 11, and 12. Here again is, well, this is page 13 of the data sheet. Here's the PIC10F200. And here's all the special function registers. It puts them at the top. And it just goes to show that the general purpose registers begin at 10H, or 10H, I should say. So maybe that's why it moves it into 10. This must be hexadecimal. But maybe hexadecimal and decimal is the same for these numbers. So it loads these all up with decimal value 5, and then it goes into the delay loop, and it'll decrement this file with 5 in it, and then it'll go to the delay loop, and it'll probably keep decrementing until it goes down to 0, from 5 to 0. And then I guess it'll go to this next file, which has 5 stored in it. And the next line, if it's not 0, will go back to the delay loop. This has already been brought down to 0. And then it'll bring this down from 5 down to 0, go to the delay loop. Once this becomes 0, it'll go to this line of code. It'll decrement this file 12, from 5 down to 0, but each time it'll go to the delay loop and get down here, and then return literal to the working register. Is that what that is? Ret LW. There's a really complicated explanation here, which I don't understand, honestly. It just seems like a return value, return literal to working register. Here's another explanation. But anyway, once it goes into the delay, then I guess it returns here. And I guess that's why a 0 is returned. And then it clears GP2 and sets GP1, which is the opposite of this. And it calls the delay routine again, returning a 0. And then it goes back to the loop again and continues blinking the 2 LEDs. So anyway, forgive my crusty attitude. And thanks for watching. And yeah, here's a new avenue of exploration. Maybe I can find some more assembly code this way.
You can see they're blinking.